Hi, my name is James Ochoa, and welcome to this wonderful presentation, this deep presentation for week 4. So I've done a little bit of research on brain development, and my topic today is like the stages and factors influencing brain development. And the one doing the presentation is me, as you can see, James Ochoa. So this is the overview of what we'll be able to talk about during this presentation. We'll come up with a definition and importance of brain development, and we'll give the outline of key stages, which is parental, infancy and childhood, and then during adolescence. And we'll talk about the factors influencing brain development, which can either be genetic, environmental, or social interaction. So to begin, we'll begin with parental brain development. Parental brain development. This is basically how the fetus brain start developing, especially when it's still in the womb. So as you can see, even from here, the first stage of this is the formation of something called neural tube formation. And this basically begins within the first 3 to 4 weeks of pregnancy. This is a critical period. And what happened here, like the, the brain and the spinal cord, it's kind of like start developing at this particular stage. And secondly, something that happened after that formation is called neuronal proliferation and migration. And once these neurons will start multiplying and migrating to the location within the brain. And this is actually an essential process for establishing the brain architecture and the most active during prenatal period, and especially, so there's one thing that is very important during this time, and that is the importance of maternal health. So maternal health, including proper nutrition, avoiding exposure to harmful substances for overall well-being, plays a critical role in the brain development or in else brain development. Inadequate intake of nutrients like folic acid is particularly important during early pregnancy. That's why some other times, most of the time, the pregnant women are advised not to take some particular medicine or to get exposed to things like mercury and some others, yeah. So, and that's the reason, and that's the first step. So the second step of brain development during infancy and early childhood development. So between birth and 2 years, an estimated over five-fold increase in dendrites in the cortex occur within about 100 trillion synapses present at age 2, according to an expert. So at this particular point, there's something called synaptogenesis and pruning that happen during the brain. During the infant and earlyhood, there is a rapid formation of synapses. This is followed by synaptic pruning. As you can see from this diagram on my right-hand side, there's something like trees here. And if you can see, these are synapses, they're like tree branches. So they are produced many at this particular point. And then if they are left like that, the communication will take a longer time. So the pruning start, meaning cutting them to make communication quicker. But in the beginning, an infant will need many of them to accommodate. And then there's a role of sensory experience. During this infancy period, sensory experience play a critical role in shaping brain development. Interaction with environment play and strengthen neural connection. That's what I'm saying. If you look at the neurons here, the synapses and the dendrites, this thing, once there's that connection or sensory experience, they keep developing. So when they are not there, the development is not there, and that does affect brain development. So, and also there's the impact of early childhood environment. So the quality of the childhood environment, including parental care, stimulation, and social interaction, signifies effect in brain development. Positive environment can enhance development, and while adverse condition may hinder it. Let's put it like, for instance, if our child is kind of growing where there's too much loud noise, and that is going to affect brain development, but it needs to grow in an environment where there's some sort of interaction, and it's okay for brain development. So now during brain development during adolescent period, like So there will be a continued synaptic pruning, meaning the sort of things that I was saying, like branches. So when there are too many, the pruning will still keep taking place so that quicker connection or sending of these neuron messages will be achieved. And also there's something that is called myelination and connectivity. Myelination is a process of forming a fatty threads around nerve fibers, including during adolescence. This improves the speed and efficiency of neural communication, particularly in the prefrontal cortex, which is crucial for executive functions such as decision making and impulse control. So this happened during adolescence, and that's why you see adolescents kind of have quicker, they're fast and everything, because the speed of neural communication increased a lot. And there's an influence of hormonal changes. So hormones changes associated with pubic significantly impact brain development. These changes can affect mood, behavior, and cognitive functions, contributing to characteristic emotional and social behavior of adolescents. As you can see, how adolescents behave in a completely different way at times. And all those hormone changes does affect brain development at this particular period. So now let's jump into the factors influencing brain development, and we'll talk particularly about genetics. Genetics play a critical role in brain development, influencing the growth and function of neural circuits. Genetics predisposition can determine individual difference in cognitive ability and behavior. So there are some traits that we inherit, and that does determine the cognitive ability and behavior of a particular person. And then the second role is the role of heritability. Heritability refers to proportional variation in brain development and function that is attributed to genetic factor. So studies show that traits such as intelligence, temperament, and susceptibility to mental disorders have a significant genetic component. Example of genetic disorders affecting development. We have a lot of them, and these are things, some we can inherit from kind of through our DNA, and some we don't. But then the one that we can inherit that affect the development are such things like autism, like Brown syndrome, caused by extra copy of chromosome 21, or fragile X syndrome. So these are whole things. Some other times you have in a DNA, but they're inactive. But once they are active, that does affect brain development a lot. So let's talk about factors influencing brain development. And this we are going to talk about environmental factors. And this has a wide range of scope and includes things such as nutrition and its impact. For instance, adequate nutrition is essential for proper brain development, particularly in the early years. That's why we're saying normally when the mother is pregnant and then she's not having enough balanced diet, food, or nutrients, that is going to affect brain development, or going to affect the development of the brain of the fetus inside or in the womb. So exposure to toxin and stress. So it's basically exposure to environmental toxins, e.g., for example, lead, mercury, can damage developing brain cells and affect neural connection. So that's why normally a lot of like mothers or pregnant women are advised not to go near things like lead, like mercury, or some other things that affect babies inside. So there's also something called socioeconomic status and educational opportunities. Children from a higher socioeconomic background often have access to more stimulating environment and educational resources. This kind of stimulate the brain and then make their brain to develop quicker, and then they end up being a little more smarter, or they think faster than a child that is not exposed to, or a child coming from like a poor socioeconomic background. Now let's talk about the last factor, which is social interaction. Importance of caregiver-child interaction. Early interaction with a caregiver are crucial for emotional and cognitive development. I'll give an example of this, like most of the some other parents who start speaking to their children or their babies when they can't listen or they can't reply back. But then you think about it later, you realize that the child or the baby will start speaking faster and listening or acting to voices very quicker. And this is sort of the things, it's the interaction between a caregiver and the child does affect brain development. Uh, there's an impact of neglect and abuse. Neglect and abuse can lead to long-term detrimental effect on brain development. That's why we are always advised that do not abuse a child because that does show up or affect the brain development. Then the roles of social support systems, strong social support system, including extended family and community network, foster resilience and healthy brain development. But in a situation where there is no support system, brain development is affected too much. Uh, and So now there's something we would like to talk about called brain plasticity. So brain plasticity or neuroplasticity refers to the brain ability to reorganize itself by forming a new neural connection. So mechanism include, so this is a kind of a situation where like when someone need to think about something they have never thought of before, a brain will reorganize itself and perform or create a new neural connection to make that happen. And for example of plastic in a difference include a child in childhood, rapid synaptic growth and pruning, critical period of language and sensory development, like critical period of language, especially learning. So the brain has to develop new neural connection in order for the baby to learn a new language. And this is what makes the brain very special. And there's something called rehabilitation and recovery post-injury. Neuroplasticity underlies the brain ability to recover functions after injury, such as stroke or traumatic brain injury. So because of neuroplasticity, even though someone gets a stroke or accident, something, the brain has the ability to recover and start performing the way it used to, even after that injury. Second thing, we'll talk about the effect of technology on brain development. So effect of screen, for instance, screen time and digital media. Excessive screen time has been linked to sleeping up disturbances, attention issues, and reduced physical activity in children. That's why they always say that children do not need to be linked too much to screen time or have too much screen time in a particular day. So interactive digital media can be both stimulating and educational depending on the content and usage. So, and the usage that we are now talking about, what are they reading and how long are they doing that for? So now, and another thing, there's the benefit and drawback of using technology, though at some point it does influence brain development or aid it. Sorry. Educational hub and program can enhance learning, improve latency, and provide access to diverse information. But however, the drawback is there. Overused can lead to addiction, social isolation, and decreased face-to-face interaction. And once a child is isolated, kind of stuck on the device, and is not having a face-to-face interaction, it leads to other things such as stress, and all those things will start develop having a lot of impact on brain development of that particular child. So research finding on technology impact on cognitive function. Studies have shown that results, some indicate improvement in visual, spatial skills and multitasking, while others suggest decline in attention span and memory. We all understand this. When you like reading paper books, and when you start reading a books online on a light, there's somehow that you don't master everything the way you master when you're reading a paper book. And this is what is highlighted very well in this research. The type of content and duration of exposure play a significant role in determining cognitive outcome. So this, most of the things we are talking about today. And on this particular topic that I've been able to recite, there are future directions in brain development research. So emerging technologies in brain research, such as advanced in neuroimaging, things to do like fMRI or PET scan, allow for detailed observation of brain structure and activity. And these are future kind of places, things we can do much more research on. And technologies like optogenetic and CREFs offer a way to study and potentially manipulate brain function at the molecular level. As you can see, even some are and longitudinal study and their importance. So these are fields where we can do much more research. And the last one is potential intervention to enhance brain development. So study like highly educational program enrichment activities designed to stimulate cognitive and emotional development. So this field is open. This is where we can do much more research and see where we can go, because this is a very wonderful field that we can actually have some good career in and impact in it. So these are the reference of things I've stated in this. I've read from sort of these authors and other books, and I've put cited all the references here. But thanks a lot for giving me this time to do this presentation. And otherwise, I hope to see you soon. Thanks. Bye.